Hello everyone. Today we will learn about the system of the forces topic and how to resolve a force and how to calculate the resultant magnitude and direction of the system of the forces. Now before going into the calculation part, we will learn the different types of the system of the forces. Now here we have three types of the system of the forces: coplanar, collinear and concurrent. Now if all the forces are acting in the same plane, then that type of the force system is known as the coplanar force system. If all the forces are acting on the same straight line, then that type of the force system is known as the collinear force system. If all the forces are acting from the single same point, then that type of the force system is known as the concurrent force system. Coplanar force system, collinear force system and concurrent force system. Now from all these three types we can get the combination of any type of the force system. Generally we will get the combination of coplanar with the concurrent force system in the problems. Now before going into the problems, first of all we should know how to resolve a force. Generally any force which is acting on any body, any random body, that force will be resolved into two components. One component on the x-axis which is known as the horizontal component or x component of that particular force, and one more component on the y-axis which is called y component or vertical component of that particular force. Now here these two components, x component and y component, are known as the rectangular components of that particular force. Now why these two components are called as the rectangular components means, generally we know that x axis and y axis are mutually perpendicular. So these x component and y component are called as the rectangular components. So every force which is acting on any random body, that force will be resolved into two components: x component horizontal component and y component vertical component, and those two components are called as the rectangular components of that force which is acting on any random body. Now here the point is, this force is acting with some inclination on that particular body. So that inclination may be adjacent to the x axis, that inclination may be adjacent to the y axis. So with that inclination adjacent to that to those respective axes, we will get the two cases. So we will see the two cases in the next paper. First case is, if theta is adjacent to the x axis, then you will get the right angle triangle in this manner from this diagram. Now here if theta is adjacent to the x axis, here this force is resolved into two components, fx component and fy component. Now from this diagram, from this right angle triangle, we can get the cos theta value and sin theta value by using the Pythagoras theorem. Now from this right angle triangle, cos theta is equal to adjacent side by hypotenuse. So cos theta is equal to fx by f. From this statement, make subject fx value. Fx is equal to f cos theta. From this formula, we can calculate the magnitude of fx component of this force. Next, again from this right angle triangle, sin theta is equal to opposite side by hypotenuse. So sin theta is equal to fy by f. From this statement, make subject fy. So fy is equal to f sin theta. So this is the formula to calculate the magnitude of the y component of this force. So these two are the formulas to calculate the x component and y component of this force which is acting on that random body when theta is adjacent to the x axis. So this is the first case. Now coming to the second case, if theta is adjacent to the y axis, you will get the right angle triangle in this manner from this diagram. Now here again f force is resolved into two components, fx component and fy component. Now again from this right angle triangle, you can get the cos theta value and sin theta value. Now from this, cos theta is equal to adjacent side by hypotenuse. So cos theta is equal to fy by f. From this statement, again make subject fy value. So fy is equal to f cos theta. Again from this right angle triangle, we can get sin theta value also. Sin theta is equal to opposite side by opposite side by hypotenuse. So sin theta is equal to fx by f. Again from this one, make subject fx value. So fx is equal to f sin theta. So these two are the formulas to calculate the magnitudes of x component and y component of this force when theta is adjacent to the fy. Sorry, theta is adjacent to the y axis. So this is the first case. If theta is adjacent to the x axis, you will get the formulas in this manner. In the second case, if theta is adjacent to the y axis, you will get the two formulas in this manner.